So welcome, John. So you were involved with the Blue Waters installation, were you not?
That's correct, with our partner Cray.
So how did that go?
It went really well. You know, we learned a lot, and the outcome of this project, working with Cray, it was a Cray Synexion opportunity, and we participated with Cray on this opportunity, and the outcome was the fastest file system in the world.
Now, how did Xyratex come to get this business? Was there a story there?
There is a story there. So this is part of the original Blue Waters project. So Cray took over for another vendor that fell off the picture, and based on the requirements for the proposal, Cray chose Xyratex to provide the storage system for the high-performance computing environment.
So what kind of numbers are we talking about as far as bandwidth and capacity?
Over 1 terabyte per second and approximately 25 petabytes of storage.
I just have to laugh because that is such a huge. Is that some kind of record or pretty close?
From all the research that I've done and all the public conferences, it is the fastest file system measured average throughput for writes.
So just in general, how is Xyratex able to achieve that kind of performance?
It's the benefit of the cluster store architecture, and with Cray, the Cray Synexion architecture. It's a foundation based within Lustre as a integrated storage solution built from the ground up with integrated hardware, software, data protection layer based on Lustre 2.1, and with our scalability platform based on the scalable storage unit, which is our 5U84 platform, which has embedded controllers with 84 disk drives, all HA embedded into it. The architecture just scaled with the number of SSUs that we had within this framework.
So John, in terms of Lustre file system, what kinds of things did you learn, deploying such a broad machine?
Yeah, so it's hard to always test Lustre stability at this scale until you have something at this scale. So we learned a lot about metadata performance with the sheer number of clients that are just connected concurrently from the system. And from the Blue Waters press, it's over 25,000 clients. And there were specific tests that test a lot of corner cases, and we had to do a lot of research and work and collaborating with Cray to provide improvements to handle these corner cases. And based on the work that we did, we uploaded those patches back to the community to benefit Lustre as a whole.
So John, with today's disk systems, it seems like you just add more devices, and couldn't anybody get to this level of performance?
Technically, yes, and they could get there with larger number of systems and larger number of drives to achieve almost the same performance we did. And with the Cray Synexion product line, they were able to achieve the performance and the capacity with far less physical devices. And in the scale, in terms of what we're talking about, of some of the research that I did publicly, up to 65% better total cost of ownership because of the integration and the testing we did, and all of the tuning that the Cray Synexion product line has shown to squeeze out as much performance per disk drive without wasting any bandwidth in the system.
So are there advantages there when you can do it with less devices? Advantages beyond just less cost for the device,
so
reliability or things like that?
Yeah, so total cost of ownership, you get better reliability, better manageability because it's built from the ground up. So the way you manage systems, upgrade software, apply patches, number of components failing is far less dramatic than normal systems that we've seen at this scale. Or even back in our old days with Lustre, we've seen much larger fallout in a much smaller scale because the integration wasn't there. And because we had a tight integration, and we do a lot of the disk drive testing, we work really closely with the disk manufacturers, and we do 2 types of testing internally, then we do another testing on the cluster store product line before it gets shipped out and becomes a Synexion product line. That type of rigorous testing and partnership we have with the industry really showcase itself at NCSA with the really good reliability numbers.
So how important is resilience to a system like this? Especially, I know there's some tough nuts as far as the folks that are reviewing this and make sure that it gets accepted.
Oh yeah, so resiliency is one of the key areas, and especially when you look at the research community, when you're looking at this large scale and they want to run applications at X number of cores on this system with 25,000 clients, the last thing you want to do is have any data interruption. You know, checkpointing is important, but between those checkpoints, you need to have access to this data continually and be able to survive any potential hardware or software glitches, and that's why HA is so important in this factor as well, because it allows you to fail over resources, have those resources online quickly, and continue what the ultimate goal is for NCSA is large-scale research.
So the Xyratex solution, the cluster store, has great advantages at extreme scale, but can smaller deployments benefit from this technology?
Oh, definitely. The only way you can always improve a product is always put it at scale. And once you demonstrate you could have resiliency at scale, then this product will be much more hardened in the departmental type environment. And with our partnership with Cray, we're just looking forward to working with them more on Cray Connecting opportunities after Blue Waters and continually going forward.